So let's say I want to find the area underneath the line y is equal to 2x plus 3 between 0 and 4, so that shaded region. Now, it is a trapezium, so I could use the area of a trapezium, the rule for finding that. So I know that that's 0, and I know that that will be 3 because that's where it's crossing the y-axis, and I can also work out this value here. Okay, so that's when x is 4, so I get 2 lots of 4 plus 3, which is 11. Okay, so I know the that height of the trapezium. So the area of that trapezium is equal to 1/2 times by the width, so 4, times by 3 plus 11. Now you could have just split this up into a rectangle and a triangle, but we could do it this way. So we get 3 plus 11 is 14. 14 times 2 is 28. Okay? So the area underneath that line, so between the line and the x-axis, is 28. Now, why would we be looking at that, having just looked at integration? Well, the thing is that integration actually will allow you to find the area between a line and the x-axis. It will also allow you to find the area between a curve and the x-axis and find that exact area, not an estimate, not like the trapezium rule or using the rectangles, but an actual correct answer. Now, this seems quite a strange thing, okay, and will appear like it's coming right out of the blue, okay. Now, there are inherent mechanisms at work going on in the background, okay, to allow this to happen, but I want to show you that we can get the same answer, 28, using integration. So, I will be integrating 2x plus 3 with respect to x, okay? And this is where things are going to change because I'm going to put the x values that I'm integrating between as limits on the actual integral symbol, okay? So to the right-hand side of the integral goes 0 at the bottom and 4 at the top. So the one on the left at the bottom, the one on the right at the top, okay? Now integration in this way has a very, very particular way of setting it out. So what we then do is we integrate 2x plus 3, obviously, because we've got to integrate it. So we're going to add 1 to the power and divide by the new power. So we're going to have 2x squared divided by 2 plus 3x plus c, okay? And we're going to put this inside a square bracket, okay? Got to be square. And the 0 and 4 now appear on the right-hand side, okay, of the square bracket. Now the 2x squared over 2, well, that's just x squared, so I'll rewrite it there. What do we do then? Well, this tells us what to substitute in, okay? So what we're going to do is we're going to substitute in 4 first, and then we're going to substitute in 0, okay? And what we do is we subtract one from the other. So we always substitute in that one first, and then take away substituting in that one. So x squared is 4 squared, so we've got 16, plus 3 lots of 4, so 3 lots of 4 is 12, and we've got that plus c, that constant of integration. Then we're taking away 0 squared, so that's 0, plus 3 lots of 0, plus c. Okay? So what we end up with is 16 plus 12, which is 28. We've got that plus c there, but we're also taking away a c, and so the c's cancel each other out. And we're just left with 28, which is exactly what I had before. Now, there's a few things to take away from this video before we kind of look at this in more detail. The first thing is that this c, this constant of integration, the fact that when you integrate, we put a plus c there, okay, when we integrate, meant that when we substituted the values in, that we're not substituting into c, so we're going to get a c there every single time, and we're going to get a c there every single time. And so actually the c's are going to cancel every single time we do this. And so there's actually no point in having the c there. So when we integrate with limits, so we're finding an area or evaluating this integral, we don't bother putting the plus c. Okay, so we're going to get rid of that, which eases up the writing, I guess, slightly. Now, on top of that, I told you that we'd be looking at something known as a definite integral. This is a definite integral. Okay, we looked at an indefinite integral before, because an indefinite integral would just be 2x plus 3 dx without limits, so I don't evaluate it. So an indefinite integral will involve putting a plus c, but a definite integral we don't bother, okay? And that is the reason why. So in the next video we're going to look at a little more about this, and we're going to find the exact area between a curve and the x-axis.